I'm now going to be recording a video about how to make a decision based off a p-value for a significance test. Some of you were still a little confused in class today. So I'm going to try to put it in terms that you maybe can relate a little bit more. I'm going to draw the normal curve right now. On the center, I'm going to make a claim. My claim is you are all going to get an A in this class. You could get it higher than an A. We're in the pretend world, or you could get less than an A. But I'm going to claim right now that you're going to get an A in the class. The claim always goes in the center of the curve. Now, what happens? Well, you get a D in the class. Uh-oh, you're upset. You come to me, you say, Miss Opal, you were wrong. You said I was going to get an A in the class. That was your claim. I say, well, no, I wasn't necessarily wrong. This D here could have just been chance variation, meaning if I flipped a coin 10 times, 6 of the times I could flip heads. That's chance variation. It doesn't mean the claim that 50% of the time you flip heads is wrong. So I tell you, okay, well, is this D significant? What does significant mean? It means I need to find a p-value associated with this. Now let me go to the next page because I'm running out of room. Let me redraw my curve. Sorry, I'll draw it smaller this time. Here's my claim of an A. Here's the D that you get. Unfortunate. So now what you have to do is you have to go through the process. You have your statistic here. You need to go through ZOMs, find a z-score. You then need to get a p-value. Now, that p-value, let's just play pretend. Let's pretend right now that that p-value you get for that D is equal to 0.01. What that p-value means for an interpretation means there was a 1% chance of getting a D or less than that. So as extreme or more extreme, right? A 1% chance of getting that D given my claim was true. Well, since it happened and there was a 1% chance of that happening, you say, and it actually happened. 1% is not a good chance of something happening. You're going to go to me and you're going to say, Miss Opal, you were wrong. There was only a 1% chance that I should have gotten a D. I actually got a D. So your claim is wrong. Okay, but now let's say the claim is still an A. This time you get a D. But the p-value associated with that is now 0.07. There was a 7% chance now of getting a D given this is true, given my claim is right. Now we say it's just chance variation. You can't say I was wrong. Why? Because my alpha is equal to 0.05. And in order to say your claim is wrong, the p-value has to be less than alpha. To just put it in a quick, handy way to say, how do I make my decision? This is in your notes, but if your p-value is less than alpha, the decision you need to make is to reject H naught. And now you have evidence for HA. If your p-value is greater than alpha, you fail to reject H naught. That means you don't have evidence for HA. Just remember what that p-value means. That p-value is the probability of getting whatever test statistic here, or more extreme, given it's true. If it's really low, if your p-value is super low, you're saying that claim is wrong. That's the quick and dirty way to kind of summarize it up. Hopefully this helps a little bit more for those of you who are struggling.